Hello and welcome back to IXL tutorials. This is Mr. Duffick, and today we are doing IXL R1, which is all about the trigonometric ratios within triangles. Specifically, we are doing sine, cosine, and tangent today. So you should have gone over the trigonomic ratios in class, but just as a very short review, we're going to be dealing with what's called Sohcahtoa today, which is a very creative way of remembering the trigonomic functions and how they relate to a right triangle like that. Okay, so for instance, is referring to S is sine, O is the opposite, H is the hypotenuse. So we have sine equaling the opposite over the hypotenuse. Ca is cosine, adjacent over hypotenuse, and then tangent is just the opposite over the adjacent. And so this is the diagram that's really going to carry you through this IXL right here. Okay, if it asks you to find the sine of a certain angle, then you're going to find the opposite of wherever that angle is, and then put it over the hypotenuse of the triangle, and then have your ratio done. Okay, that's just an example. So we'll use this diagram for this IXL, kind of like that. And so we'll go to our first problem here, and we see that the problem asks us to find the cosine of angle F. Okay, so if I translate this triangle here, we'll see that 8 is right here, 15 is down here, 17 is the hypotenuse, and angle F is going to be right here. So it wants us to find cosine of angle F. So we're going to be dealing with cosine, or the ca in Sohcahtoa, meaning we're just going to put the adjacent side of where F is over the hypotenuse of the triangle, and that's going to be our answer. So we go to F, corner F right here, and the adjacent side is going to be the side that is intersecting at F, at the point F. That is not the hypotenuse. Okay, so we are at F right here, and we see one side that is connected to point F is the hypotenuse. We're going to leave that alone. And this right here is going to be our adjacent. Okay, it's the adjacent is always the side that is touching the point. It's next to the point. Remember, adjacent always means next to. So what that is going to be 8. So we have 8. And then over our hypotenuse, right? Adjacent over hypotenuse. So we did the adjacent over the hypotenuse of the entire triangle is 17. And that's all. It's just 8 over 17. Okay, and then IXL says that it wants us to simplify your answer and write it as a proper fraction, improper fraction, or whole number. Okay, so our fraction again was 8 over 17. Can we simplify that in any possible way? 8 over 17. Nope, 17 is a prime number, so we're going to leave that alone. And that's all there is to it. Okay, we'll do another one here. This is cosine, and it wants us to find u. Okay, and we'll just do that. Go there, okay. And so remember, cosine is ca, Sohcahtoa. So it's going to be cosine of our angle. We'll do x equals the adjacent over the hypotenuse. So for this one, it's going to be cosine of q equals, what's the adjacent side of q? So we're at q right here. We have here, this side right here is the hypotenuse, so we're going to leave that alone. And then the side that is also touching q is going to be our adjacent side, so that's going to be 5. And then all over the hypotenuse, which is 13, because again, the hypotenuse is always the opposite side to where the 90-degree angle is. It's always opposite. It's always the opposite. Okay, so it's just 5 over 13, and that's all there is to it. 5 over 13, and you could use the little fraction thing here if you want. It doesn't matter. Okay, here's one for tangent. So tangent, we're going to write already, is Sohcahtoa. So Toa. Tangent is opposite over adjacent. Okay, that's what the TOA stands for. And so we're going to go to our problem here, and it says it wants us to find tangent of C, so it wants us to find the tangent of this angle here. Okay, so we have the opposite of where this angle is. That's going to be over here. The opposite side is 30. So tangent of C is going to equal 30. And then over the adjacent side, that is not the hypotenuse. So right here we have C. This side is the hypotenuse, so we're going to leave that alone. And so the other side is going to be the adjacent side. It's going to be the side that is next to C, or right there intersecting with C. So it's going to be 16. Okay, so 30 over 16. So we're going to go back. We're going to write 30 over 16. But remember, it wants us to simplify. So how can we simplify 30 over 16? Well, immediately, I would say you can simplify by half. And so that's going to be 15 over 8. Is there any way we can simplify anything past 15 over 8? Nope, not really. So we're going to say that is our answer. All right, here is one for sine. We'll do one for sine now. Okay, so in Sohcahtoa, so is spelled like that. So we have sine of whatever angle equals the opposite over the hypotenuse. Okay, and so it says sine of angle D, so D is right here. Okay, so sine of D is going to equal the opposite side of where D is. So the opposite is going to be 48 over the hypotenuse. The hypotenuse, again, is always the side that is opposite of the right angle, which is 52. So it's going to be 48 over 52. Then we got to simplify that down. So we'll do 48 over 52. Okay, let's try taking half of each. So half of 48 is going to be 24. Half of 52 is going to be 26. Okay, can we reduce that down any further? Yes, we can. We can do it by half again. So half of 24 is 12, and half of 26 is 13. And can we simplify that down any further? No, we cannot. So that is going to be our answer, 12 over 13. Cool. Okay, so you see they're pretty much the same problems here. I'm going to jump, see if there's anything different. What is cosine of y? Okay, that's fairly obvious. It's just adjacent over the hypotenuse. So 3 square roots of 7 over 3 square roots of 10. Okay. Cosine of g. So 10 square roots of 2 over the hypotenuse. Okay. Well, for this one, it's going to ask you to do an extra step, essentially, because they don't give you all of your sides. So we'll do this one. Okay, so first we know that Sohcahtoa, or is cosine of x equals the adjacent over the hypotenuse. Okay. If we're doing it of g for this equation, we see the adjacent is 10 square roots of 2, but we don't have the hypotenuse, so we got to find the hypotenuse. And how can we find the missing sides of any kind of right triangle? That is, of course, going to be Pythagorean Theorem, which is a squared plus b squared equals c squared. Okay, so a is usually the shorter leg, b is usually the longer leg, and c has to be the hypotenuse, or the side, again, that is opposite of that 90-degree angle. Okay, so we'll start plugging numbers in. So 10 square roots of 2 all squared plus 10 square roots of 6 all squared equals c squared. Okay, now we solve. 10 squared is 100, and then square root of 2 squared is just 2, so times 2, plus 10 squared is 100 times the square root of 6 squared is just 6, then equals c squared. So we'll distribute, and it's 200 plus 600 equals c squared, or just 800 equals c squared. Okay. And so now we don't want to find c, we want to find c squared. So we got to take the square root of 800. Okay, and let's see what we can take out of here. Okay, so let's take a 2 out. In order to do that, we have to go, let's see, 2 times 2 times 200. Right, 2 times 2 times 200 is just 800, so we factored out 2's. And if we have 2 the same number in there, then we can factor it outside the radical. Let's see, so it's 2 square roots of 200 now. Okay, can we do something like that again? Yes, we can. So we'll go 2 times 2 times 50, right? 2 times 2 times 50 is 200. So that's going to equate to 4, because now we can drag the 2 out, right? 2 times 2 is 4, and then we are just left with 50. And can we do anything there? Yes, we can actually take a 5 out. So this could be 4 square roots of 2 times 5 times 5, right? So 2 5's there, meaning we can take a 5 out. So 4 times 5 is 20. Then square root of all we have left is 2. So 20 square roots of 2 is going to be our hypotenuse. So C is 20 square roots of 2. Okay, great. We finally found the hypotenuse, right? Not our answer. We are still trying to find cosine of g, but now we can actually accomplish it. So I'll go back up here, and cosine of g is going to be the adjacent, which is 10 square root of 2, all over our hypotenuse, which we just found to be 20 square roots of 2. Okay, and now from here we can simplify. The square roots of 2 are going to cancel out, so we're left with 10 over 20. You can divide both by 10 or just remove the zeros, and we are just left with 1/2. Okay, and that's it. Cosine of g is just going to be 1/2. So we'll go 1 over 2. Beautiful. Okay, so just work your way from there, and I'm going to jump another level or two just to see if there's anything different or unique. And there is not. Here, they just ask you to find the sine and the cosine and the tangent, not just one, which is a little bit more work, but it's the same exact problem. So this is where I am going to stop. Okay, so stay safe, study hard, and I will catch you for the next IXL tutorial video later on. Goodbye.